Okay, this is going to be a few problems from page 734, the practice, chapter 10 practice here. I'm going to look at number 3 and number 4 here, pretty much at the same time. This is a parallelogram. The formula area of it is base times height. Obviously, this is a triangle. The formula for that is 1/2 base times height. In both cases, you've got to know what the base and the height are. Now, base and the height, that's two dimensions here, and you've got a 13, 11, and a 12. You've got 3 to choose from. You got to know which 2 of those 3 is truly the base and the height. The base is always going to be one of the 2 sides. The height is going to make 90 degrees with that base. So if you look at this one carefully here, there's the 90 degree. This line 11 would be the height to this base here. So always look for that 90 degrees. Now, of course, if it's 13 on top, it's 13 here. So you want to go base, it's one of the side lengths, times the height. Now, what about the 12? Oh, excuse me, 11 is the height. And then whatever that is in the calculator. The 12 here is not part of solving the area for this particular problem. You would have to see another line here that's 90 degrees with the 12, so I'm just going to draw that. Now, this 12 and this height could also figure out the area. But you always look for the 90 degree angle. So again, with the triangle here, it's 1/2 base times height. You've got a 17, you got a 17, you got a 12, you got a 13. Which 2 numbers are considered the base and the height? Again, look for that 90 degree angle. The height and the base, those 2 together create that 90 degree angle. So in this particular problem here, this is 1/2 17, this 17 by the way, times 12. All right. What about the 13? Well, that could be the base. This 13 could be the base if you saw this blue height. But they don't give you this blue height, so we're not using the number 13. Okay, don't always just go side times side. Know which 2 numbers are being multiplied. Okay. Okay, now going on to number 5 here. This is obviously a triangle, so we would go, the formula is 1/2 base times height. Again, they give you 2 numbers here. Don't assume it's 26 times 24. That's not going to be correct. Always the base and the height form 90 degrees. So look for that 90 degrees. So it's this line and this line that form 90 degrees. So the 26 there is really kind of meaningless. It's not part of the problem. So we need to figure out what this is before we go base times height. And of course, that's going to be x squared plus 24 squared is equal to the hypotenuse 26 squared. Calculate what this is, and then your base could be x, whatever that value is, and then your height could be 24, or vice versa, since they both make 90 degrees. So the 26 really is not used for base times height. It's used for the Pythagorean theorem. Okay, I'm now looking at number 26. Hope get focused here. And they want us to figure out the length of the red line there, the arc. And they also want us to figure out the circumference. So part A is the complete circumference. Circumference is 2 pi r. And so you got to know what the radius is. This diameter is 6. So half of the diameter, of course, is 3. So that's the radius. If the diameter is 6 all the way across, the radius is 3. So the circumference of this guy is 2 pi 3, which is a 6 pi. You can leave it like that, or you can multiply it 6 times 3.14, 18.8. This happens to be in centimeters. So it takes 18 centimeters to go around this entire circle here. If here to here is only 3 centimeters, then to go around 3, 3, 3, 3, 3, it would be about 18.8. Well, now the part 2 says, well, how far is it to go around just this arc? You know it's going to be less than 18.8 because that's going all the way around. There's something I left off this picture here. There's a 120 degrees there. This 120 degrees will help figure out, well, what percent of the arc is red? The way we would do that is 120 over the entire circle. To go around a circle is 360, and we're going to take that and multiply it by the circumference, 2 pi r. Radius is 3. We already know 2 pi r is 18.8. So let's take a look at this fraction. 120 divided by 360 is 1/3. So 1/3 of the circle is this red arc, And then you're going to, this again, this is the circumference number, multiply 18.8 by 1/3. And so this answer will be approximately, this is the arc in red, 6.28 centimeters. Okay, that is 1/3 of all the way around. If you want to leave it in terms of pi, it's 6 pi to get around. And so the arc could also be 1/3 of 6 is 2 pi centimeters. Okay, I'm going back to number 9 here. I've skipped this one for some reason. Figure out the area of this regular figure. Now it's a triangle, so we would call this an equilateral triangle. If it's 5, it's 5, 5, 5 all the way around. And the formula for any regular figure is going to be 1/2 apothem times perimeter. Because it's a triangle, you could also go 1/2 base times height, but I'm going to go 1/2 apothem times perimeter because that will help solve any type of regular figure. We're going to need the apothem, which is here to here. The perimeter won't be a problem because it's 5 plus 5 plus 5, but the apothem is going to be an issue. So what you got to do here is get some angles and then use some trigonometry. This would be from the center, it's 360 degrees. I drew these 3 radiuses, so I'm going to divide by 3. That's 120 degrees. 120, 120, and then the 120 gets split into a 60-60. So I'm going to enlarge this one triangle here off to the side. This is the apothem that we want. And that 120 gets split into a 60 degrees, a 30 degrees here. And even this 5, this is now half of 5, 2.5. So we're going to use sine, cosine, or tangent to figure out the apothem here. You can stand at either 30 degrees or 60 degrees. It doesn't really matter. Let's go with the 30 degrees. Let's go tangent of 30 is equal to A, the apothem, over 2.5. Opposite over adjacent. Opposite over adjacent. So the tangent of 30, you're going to need the calculator's help here, is 0.5773. And then multiply by 2.5 to both sides. So I'm going to multiply by 2.5, and you get an apothem of 1.44. So that is the apothem. And now we just plug that into the major formula. 1/2 apothem times perimeter. Perimeter again is, each side is 5. There are 3 sides. So then you just multiply all of this out. And your answer should be about 10.8 millimeters squared, because this was in millimeters. Okay, that's number 9, regular figures, 1/2 apothem times perimeter.